Alrighty, today's objective is students will be able to evaluate expressions using the quotient of powers rule. Okay, and we should know that quotient means division. Again, that's another one that's the most common one that students forget. Quotient means division. Quotient means division. Okay, get that down. If you're not done writing the objective, hit pause. Okay. This is very similar concept to the last objective, and we're going to see a pattern with this as well. Okay, if I write out 3 to the 4th power, again you guys are writing this in that middle box, it would be 3 times 3 times 3 times 3. And if I write out 3 to the 3rd power, it would be 3 times 3 times 3. Now, if you just look at this 3 over 3, what happens with any number over itself? Any number, any variable, anything over itself. I could put a smiley face. That kind of looks like a mean face. We'll do the same thing. I could put the two faces over each other, and what's going to happen? They're going to cancel to be 1. Get that out in the margin. Anything over itself is 1. Okay? So 3 over 3 will cancel out to be 1. 3 divided by 3 will cancel out to be 1. And 3 divided by 3 will cancel out to be 1. What's left? A 3 to the 1st power. 3 to the 1st power is just 3. Okay? With 5, let's do the same thing with 5. Let's write it out. And again, you guys have that middle box to write this out. It's 4, 5, 6, 7 5s over 4 5s. So 5 times 5 times 5. Okay. What happens with 5 over 5? Cancels. 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 Okay, these don't cancel. There's nothing on the bottom for them to cancel with. Okay. So what's left is 5 times 5 times 5. Another way to rewrite 5 times 5 times 5 is 5 to the 3rd power. Okay. Remember from the last objective, if you have a number raised to a power, you should always simplify it. 5 times 5 times 5 is 125. And again, you can do that in your calculator. Circle both answers. Again, we don't know which way it's going to show up on tests. Okay, so you need to be prepared to write both answers. This one is the best one, the 125, because it is simplified all of the way. Okay, on the homework and quizzes, you need to write the simplified answer all the way. We can extend this, same concept. Okay, this would be, because the negative 2 is in parentheses, negative 2, okay, times negative 2, times negative 2, 2, and negative 2. Okay, over negative 2, negative 2, negative 2. Okay, what happens? Cancels. What's left? What's left is negative 2. There are 2 of them, so to the 2nd power. When you do that on your calculator, you will end up with 4. A positive 4. Okay. What about this one? Well, it would be 8 times 8 times 8 times 8 over 8. Okay, remember we should write what in here? A hidden 1. Oops, I need to make sure that goes a little bit higher. And make sure your exponents are all the way at the top of the number. Okay. Cancels out. Just one of them does. So you have 8 to the 3rd power left. Okay, go ahead and do that in your calculator. 8 to the 3rd power. And you get 512. Okay? Now, you should already start to see this. Similar pattern to the last time. Okay, when we were multiplying, we figured out that we could add the exponents. Okay? But when we are dividing, okay, think about how we got to the 2nd power. What can you do with these 2 exponents to get to the 2nd power? Well, you should see it. Same with these, right? We ended up with 8 to the 3rd power. Between these 2 exponents, how would you end up with 8 to the 3rd power? Okay, it should be pretty obvious now that we would subtract the exponents to get there. Okay, and that's going to be a key point that we'll write in a minute, but I wanted to show you. Again, it's not just a rule that we made up. This right here proves the rule. We can show it the long way, and it proves the rule. All right, let's do this one quickly. Okay, this one would be negative 2 times negative 2. Okay, and that is going to get us a positive 4. Okay, Now on this one, you would have a negative 2 times negative 2 times negative 2. Okay? Now, a negative times a negative, okay, a negative times a negative will get me a positive. But then I still got to multiply it by this negative. So then a positive times a negative will give me a negative, and that would be negative 8. So if you actually do that on your calculator, if you do in parentheses negative 2 raised to the third power, you're going to get a negative 8. Okay? Now, I want you to make a note on this. The number 2, is that an even or an odd number? Okay? And the answer is that's an even number. Okay? Look at the 3. Is 3 an even or an odd number? Okay? And you should know 3 is an odd number. Okay? It's really important. Let's do 2 more examples that kind of highlight showing you a discovery that's going to lead to a key point. Okay? If we do this one, it would be negative 2 times negative 2 times negative 2 times negative 2. Okay? If you just do this on your calculator, you're going to end up with a positive 16. Okay? And the reason why is negative 2 times negative 2 is a positive 4. Negative 2 times negative 2 is a positive 4. And we're still multiplying in between. Okay? So what is a positive times a positive? It is a positive. Okay? But on this one, okay, again, write it out. Negative 2, negative 2, negative 2, negative 2, and the last one, negative 2. Okay? Let's show what the 2 numbers multiply to get. So this would give me a negative times a negative gives me a positive 4. Okay, times, because it's touching up here, a negative times a negative gives me positive 4. And then I still have this negative 2 that I need to multiply it by. Okay? So what is a positive times a positive? Well, this gives me a positive 32. But then I need to multiply it by this negative 2. I'm sorry, that gives me a positive 16. I was getting ahead of myself. A positive 16. Make sure you change that. But then positive 16 times this negative 2 will give me a negative 32. Okay? Notice on this. Okay? This is an even exponent. 4 is even. 5, though, is an odd exponent. Okay? So look at the other ones. The even so if you have a negative number in parentheses, you have a negative number in parentheses, and it's raised to an even exponent, okay, is your answer going to be positive or negative? And we just saw from these, if it's raised to an even exponent, the answer is going to be positive. Okay? Well, if we have a negative number in parentheses that's being raised to an odd exponent, is that going to get you a negative or a positive answer? And the answer is it's going to get you a negative answer. So let's make a key point out of that. Let's just show negative number raised to an even power, okay, gives me a positive answer. Okay, so that's kind of one key point. The second one, though, is a negative number raised to an odd power, okay, leads to a negative answer. All right, really important that you keep that in mind, okay, because as we get to some more difficult problems, especially in practice. So, the property, or again, this is the law in words, okay, when we are dividing powers. Okay, so let's get this in words. Okay. When dividing powers, okay, we simplify coefficients. We simplify coefficients. okay, and we subtract exponents of same bases. Okay, get that down. Okay, if you're not done writing, make sure you hit pause, otherwise we're going to go on. Okay, so in numbers, we can show something like this, where we can let's just show 15 raised to the 6th power over 15 raised to the, let's just do 5th power. Okay, the way we show our work on this is 15 raised to the 6 minus 5, which is equal to 15 raised to the 1st power. Okay. Now, if we want to show this in algebra, and again, this is a type of kind of critical thinking problem that they may try to trick you on the ACT. A to n power, a to whatever power, over a to an m power. Okay. They have the same base. So what can we do with their exponents? Well, we can subtract. So we keep the base, and then it's n minus m. Okay. All right, let's go on to okay, this one. Example number 1. Okay, same base of 99. So we just do 99. This is the work that we'd show on homework, to the 4 minus 3, because we subtract the exponents. And I end up with 99 to the 1st power. Can't simplify that anymore. All right, example 2 is a little trickier, okay, because we have some multiplication here. Now, this x to the 8th power, okay, how can this other one is a fraction. Like if I give you the number 5, and I say multiply that by 2/3, you don't have to write this down, okay, you would turn this other one into a fraction. That way you could just multiply across, right? We're going to do the same thing with this. Any number, anything, can be written over 1. Okay? And then once you do that, we can just multiply across. So that would give us x, the coefficient here, okay, 1 times 1 is just 1. So you end up with x to the 8th over 1 times the 1 will give you 1, x to the 3rd. Now, are we done simplifying? And the answer is no, because we need to divide these. How do we divide? What do we do with the exponents? We subtract. So this would be x to the 8 minus 3, which will give me x to the 5th power. And I can't simplify that. It's not a number. I can't plug that into my calculator and simplify it at all. Okay, okay, this one, w. Okay, are there any w's on bottom to subtract the exponents? And the answer is no. For right now, though, I want you to show, though, what we actually do. So this is w to the 4th, okay, minus, are there any w's in the denominator? And the answer is no. Just show minus 0. There are no w's down there. Okay, but z, we do have 5 minus 3. Okay, and again, you don't need to write this out, but I want to show you. Okay, I want to show you what this would look like. Actually, you do have room to write this out. This will just take a second, because again, this proves the rule. Okay, so let's write this one out. I think you have some room underneath in your notes. W times W times W times W, and then Z times Z, this is in the numerator, over Z, 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 3 Z's. What's going to happen? Cancel, cancel, cancel. What's left? Well, we have W to the 4th power, 4 minus 0. Oops. So W to the 4th power, okay, and then Z to the 5 minus 3 is 2. And we proved it right here, right? How many z's are left? Well, there are 2 z's left. This is your final answer. Can't do anything else with that. Okay. All right, the next one. 24 over 8, 24x to the 4th over 18x. Oh, doesn't have an exponent. Let's write it in. Okay. And then what we need to look at is, first of all, we need to simplify, and I want you to write this. Simplify coefficients. Okay, simplify coefficients. Okay. Now, if I look at 24 and 18, okay, one, you can just, we'll check it on our calculator at the end, but let's try to simplify without our calculator right now. To do this, we need to find the greatest common factor that goes into both 18 and 24. Okay, the greatest common factor. Well, let's just start with factors of 24. And we know that they can't be bigger than 18. So the first biggest factor, 24, that's not bigger, is 12. Does 12 go into 18? And the answer is no, 12 doesn't. Okay. I think the next biggest would be 8, because 8 times 3 is 24. But does 8 go into 18? And the answer is no, it doesn't go into it evenly. Okay. So then I'm going to go down. 7 doesn't go into 21 or 24, but 6 does. 6 goes into 24. Does 6 also go into 18? And the answer is yes, it does. So 6 is my GCF. So let's just write that down. GCF is 6. So I'm going to divide both of these by 6, divide by 6. Okay, that leaves me with 4 over 3. Okay, now, because you can use calculator on the ACT and tests, double check this. Everyone on your calculator, punch in 24. So if you have one of the blue calculators, you can punch in 24 fraction, the fraction button, 18, hit equals, and it'll give you 1 and 1/3. Well, if you hit that, that's a mixed number, right? We don't want that. If you hit the second button in the fraction again, it'll say, oh, convert that to an improper fraction, and it'll give you 4 over 3. Okay. Now, if you have a graphing calculator, you can do 24 divided by 18, and then convert that to a fraction. Okay. But it reduces to 4 over 3. Okay. Now we have to show our subtraction of our exponents. So this would be x to the 4 minus 1. Okay. So my final answer on this is going to be x over 3, and then right in the middle I'm going to show 4 over 3 x to the 3rd power. Okay. Now another way that this might show up on the test would be this. Because this x to the 3rd power, and I'm just going to do it up here, x to the 3rd power can be written over 1. So that the x to the 3rd power is in the numerator. So we could actually show this x to the 3rd power in the numerator with the 4. Okay. So either one of these, and I actually want you to write down both of these, either one of those could show up as the answer on the test. Okay. Alright, next example. Before we start subtracting our exponents, we need to simplify numerator. Get this down in your notes. Numerator and denominator. Denominator first. Okay. So if we look at this numerator, can we simplify anything up here? And the answer is yes. This x to the 3rd and this x to the 4th, we can add those exponents. So I'm going to rewrite it to be 2 to the, well, x to the 3rd and x to the 4th, when you add the exponents, would get you x to the 7th power. Okay, and then you have w to the 4th power, and then you have z. Okay, and that's all over. I can't simplify this denominator at all, so that's all over x, w, z. Okay. Now, what's the hidden coefficient in the denominator? Well, there's not one there, so I know it's just a 1. Okay. So when you simplify the coefficients, 2 over 1 just stays 2. Okay, so I'm going to start writing my answer. It's going to be 2, x to the 7 minus 2, okay, w to the 4 minus, would I put a 0 there? And the answer is no, right? Remember, there's that hidden exponent of 1 on each one of these. So it would be 4 minus 1, not 4 minus 0. 4 minus 1. And then z to the 1 minus 1. Okay? So when I write this out, now I need to start writing these in alphabetical order. okay, because I'm getting close to my answer. You could have changed it up above at any point. I like to just do it at the end. Okay, so M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. W, X. So W comes first. So it'd be W, let's see, to the third power. X to the fifth power. And Z to the 0 power. Okay. Now, we're going to learn this in a later objective. Okay. But I want you guys right now, pick any two numbers, and raise it to the 0 power and see what happens. Okay. Now, the numbers I picked are -6 raised to the 0 power, and it gave me the -1. Okay. If I put that in parentheses, if you picked a negative number, make sure that you put it in parentheses. But let's just do 20 raised to the 0 power. Going to get you 1. Okay. We're going to learn this in the next objective, but anything raised to the 0 power basically just cancels and is actually 1. Okay. So we don't need to include that in our final answer, because if we do 1 times the 2, it's still going to stay just the 2. So our final answer is 2w to the third power, x to the fifth power. Okay, that's our final answer. Okay. Another way that you can think about it with those z's is if you look at it in the original problem, what's going to happen with a z over a z up here? They're just going to cancel out. Okay, so they basically go bye-bye. They cancel out. Okay. All right, next example. Okay. What should we always do first? We should see if we can simplify the numerator. Can we simplify the numerator at all? The answer is yes, because we have a w to the fourth and w squared. Okay, and let's just put that x to the first power now. Okay, so when I simplify the numerator, it would be 18. W comes first. 4 plus 2 is 6, and then you have x to the first power. All over 6w to the third. Okay. Well, can we simplify 18 divided by 6? And the answer is yes. 6 goes into 18. It goes into it 3 times. So that would simplify to 3 over 1, or you could just write 3. Okay, and then you would have w to the 6 minus 3, and then x to the 1 minus, are there any x's down here? No. Okay. Essentially, when you're subtracting 0, again, that's not going to change anything. It's just going to stay x to the first. So your answer on this would be 3, w to the third. Oops, that's an ugly 3. W to the third, and then x to the first. That's your answer. Okay. All right, last example. Okay, on this one, again, see if you can simplify the numerator at all. And you may be saying, well, yeah, I could multiply 2 to the second power and 3 to the third power. But a smart cut on this, because if you do that, if you just plug in that numerator and multiply all that out, you're going to end up with a huge number. In fact, it probably won't even fit on your calculator. Okay, so when that's the case, we can use our quotient rules to help us simplify this. Okay, so this one would be 2 to the 2 minus 1. This one would be 3 to the 3 minus 5. And then this one would be, oops, not equals, still multiplying all these. This would be 5 to the 9 minus 2. Okay. When we simplify this, it would be 2 to the first power, 3 to the negative 2, and then 5 to the 5 to the 7th power. Okay. Now, for right now, we're actually going to leave this as our answer. And the reason why, we have not learned about negative exponents yet. We're going to learn about negative exponents in the next objective. So for right now, we can just leave this answer. But I do want to show you, and I do want you to get this down, how this would actually look. So if we look back at the original problem, okay, if I wrote out my numerator of, I'm just focusing on the 3 to the third power over 3 to the fifth. Oops. Okay. That would cancel, that would cancel, that would cancel. Okay. Where are my 3 2's at? I'm sorry, let me say that again. Where are my 2 3's at that I'm multiplying? The answer is they're in the denominator. Okay? Whereas I have more 2's in the numerator and I have more 5's in the numerator. Okay? So how this would actually look, and I want you to get this down, is this would be 2 to the first power in the numerator times 5 to the 7th power over this 3, this negative exponent. This shows me that that's actually going to be in the denominator. Okay? And then actually do this on your calculator. Let's do it. So let's do 5 to the 7th power times 2. Okay, and we end up with, let's see, 1,56250, so 156,250, all over 3 to the 2nd power is 9. So on your calculator, just divide that by 9, okay, and you're going to get a decimal. Let's convert it back to a fraction, see what happens. It's not going to let us do it. So our final answer on this, if you look at your calculator, would be something like 1,000. Let's see, no, not 1,000. It would be 17361.1 repeating. Okay, so 17,361.1 repeating. Okay, if you don't understand the negative exponent there and where we got that, that's fine. We're actually going to learn this in the next unit. But we wanted to start to get you thinking about, if you have numbers, you can still use the smart cut and use the quotient rules and subtract the exponents. Okay?